All right, we'll go ahead
Okay.
and start. Thank you. Thanks everybody for attending today. We really appreciate you taking some time to spend with us today for the first healthcare webcast. So we're going to discuss ensuring patient safety while modernizing healthcare facilities. So at the core of that discussion, it's going to be managing aging infrastructure while maintaining the highest standards of patient care and safety. So we're going to go through a couple of topics here: maintaining continuity of care, code compliance and regulations, upgrading versus replacing infrastructure, benefits of Tier 4 final generation. We got a great panel with us today. So Rod Allen from Lee Memorial Health System, thank you for taking time to be here today. And George Baker from Retired, congratulations. I aspire to be you someday. From Wellspan, thank you for making the trip in. And we have Dan Chisolm on the phone. Dan, thanks for taking time and being part of the panel today.
You're welcome.
So we have a few points that we're going to discuss, but we really would like during each of the discussion points, if you would like to ask questions. We don't want to wait to the end. We want to be able to address questions and comments and concerns as we go through the presentation. So those of you that are familiar with Teams, there's a raise your hand button at the top of the screen that Adam will be able to see, or either just in chat, if you would put the question in chat, and then Adam can read the question from there. So without any more hesitation or commentary, we'll just dive in here. So Rod, when you're evaluating the facility infrastructure, what's the first steps that you take?
Well, whether you're new or seasoned person in the healthcare environment, one of the first things you want to assure is that you're looking at your life safety systems. And that's generally all tied around your electrical distribution, because in healthcare, one of the most important thing is reliability of power to your facilities. Without power, nothing else in healthcare happens. That's really where it starts at. And it's really a continuous process. So when you start to look at a facility, and I've been lucky or blessed to be able to walk into new facilities that I'm not familiar with, build greenfield facilities, close facilities that had a aging infrastructure. And one of the things that I first do is start to look at, all right, what do I have here? What's the age of my equipment, my transfer switch gear, my generation systems, my distribution boards, things like that, and start to look at that. What's the age of these things? What condition are they in? Are they being well maintained or not? And then you start to look at the documentation. How was the runs? Have we had any long runs on the systems, or have they just been doing the monthly half an hour runs? So you start to look at all that, and that starts to give you a picture of where you stand, where your base is. So that's how I kind of focus or start on a new facility, or even existing facilities that I'm very, very familiar with. It's a continuous process of looking at that and talking to your technicians and your folks out there.
So I can imagine you probably have some real-time monitoring on some of these assets as well too. So does that kind of drive, all right, I've seen something that's becoming a trend. Now I need to go do this at a different interval than what I do normally for identifying those single points of failure?
Well, sure. I mean, your monitoring is really your key. What is happening? Am I starting to see a load increase or decrease? And the only way to know that is through trending data and looking at your monitoring and having good reporting structures to be able to look at that. One of the challenges is why, if I'm increasing load, why am I increasing load? Or if I'm decreasing load, why am I decreasing load? Or things like of that nature. Then it starts to run you down certain rabbit holes, if you will. But you want to make sure you don't get too far down a rabbit hole, because you could be going down the wrong path.
Yeah. We've been there before.
Absolutely. Absolutely.
All right, so Dan, I can imagine that it's imperative to know those single points of failure. So how often should you conduct the risk assessments?
Well, first of all, if you're a new director going into an older hospital, the first thing that I would tell administration was you need to let me do an inspection of the hospital because I don't want to be blamed for something that wasn't my fault. So, and we do this a lot because, as you know, healthcare groups are acquiring hospitals and they're dumping hospitals daily. You never know who's going to be in charge. And as a director, I can only relate that to a ship's captain. They give him a boat, but it's 20 years old, and they expect him to run that boat. Well, what if something happens to that boat? Are they going to blame him, or are they going to go back 20 years and blame the commissioning agent for not finding something? A single point of failure. A lot of people think, well, it's the transfer switch gone bad, it's the generator gone bad. Well, no, it's not. It's something inside those components that went bad. And that's what you got to look for. And I'll give you a couple of examples. I mentioned this in the paper that I'm going to post on ASHI, hopefully today. But we had one level 1 trauma center that was responsible for 14 counties and a state, and I won't mention the state. But they had been in business for 12 years, and they'd never had a power failure that lasted for more than probably 45 minutes. And the only other time the generators ran under load was when they did their 30-minute test. Well, 12 years later, they have a power failure, a big power failure that lasted over 3 hours. Well, the generators ran fine for 2 hours before they didn't. And those day tanks, to tell you the bottom line here, the day tanks were all sized for 2 hours worth of fuel at existing load. Well, when your pumps are powered from a non-essential panel, bad things are going to happen. When they lost utility power, the day tanks emptied and the generators quit. And here we have a 700-bed hospital that's in the dark. They were found liable because 2 patients were compromised. But that single point of failure happened to be the contractor's inexperience in landing cables where they should have been landed. But a good commissioning agent, had he been a person that had had a lot of field experience, had commissioned that job, he would have found it in the beginning, but they didn't. They overlooked it. As a matter of fact, the hospital did not want to pay for the extra commissioning assignment, and they paid for it 12 years later. Something like that hopefully will never happen to anybody that y'all know, but it could. Somebody asked me the other day, well, what about a single stage filter on a generator? That's a single point of failure if you think about it. If your generators don't have at least a dual or a triple stage fuel filtration system, you may have an issue, especially during long runs. And Rod, I know you're familiar with long runs. I think we wrote a paper a couple of years ago where you were down for about 98 hours.
Oh, yes.
And if that fuel wasn't clean, which I don't want to stretch this out, but you've got a fuel policy system that kept your fuel clean. But bad things can happen. Last year, September the 27th, we were in North Carolina when that hurricane came through, and we took a direct hit. No damage to the house. We lost 7 trees, and I've got a 40 kW generator sitting outside. And I'm wondering to myself, did I fill that tank up appropriately before that storm hit? Because nobody up there expected this. Generator ran for 288 hours. And then I changed oil. And I'm kind of segueing a little bit here, but not having spare parts on the shelf to take care of something like this is a single point of failure, if you think about it. Fortunately, I had oil, I had filters, I had a belt, a battery on charge. So I was ready for it in a way, but I kept thinking, how full is that propane tank? It could have been a single point of failure. Fortunately, it lasted.
Yeah.
But, you got to think courtroom. Anytime that you take over a hospital or anytime that you take a new one and put it in, I'm trying to see here, getting mumble mouth. It's been a long night. But once you take over a new hospital, you need to put that sucker under a load. And I'm not talking about a 30-minute load. You need to run it for 4 hours. You need to simulate a power outage. In a courtroom, bad things can happen if you don't do, let's just say, go beyond the code. I've seen attorneys make a very good director look terrible because he asked a question. He said, what code are you using? Well, 2010 NFPA 110. Oh, okay. Have there been newer editions? Well, yes. The 2024, whatever it was, has been published. Why didn't you use that? Well, we didn't have to. The attorney looked over and, he's got 12 people sitting there in the jury that didn't know how to get out of jury duty. So you can imagine how much they knew about what was being explained to them. But that's what they heard. They did not use the latest code. And to me, whenever I talk to folks, I say, you better use the latest code because a litigator will if he's got you in a courtroom.
Well, Dan, you bring up a good point there is that, the codes are minimums. And depending on where you're at in the country, in the world, you have to look at the environment around you. I'm in South Florida. We have hurricanes. Every year, I run my generators for at least 4 hours in February to make sure that they're going to stay operating when I get into hurricane season. So if there's anything I need to do where we find an issue, we start then and we know what we have. But,
Right.
And it's only required that even the new codes, you don't have to run it for 3 hours every 3 years, I believe is the code. And that, it doesn't make sense for me. I'd rather do it every year and know what I have before I get into a need situation. So.
Well, it makes sense. Interestingly, after that one incident at the hospital that I mentioned, the technical committee from 110 got together and said, maybe we should put something in the code or in the standard, just because it's not a code necessarily, but to address that. So that's where section 8.4.9 came in. Every 3 years, you need to run it at least under 4 hours with all equipment attached, all transfer switches. Basically, you're pulling the plug, for 4 hours to see what happens. I think that's one of the best things we did in NFPA 110 was to place that in there.
So kind of moving on there a little bit, Dan, I appreciate it. So George, hospitals, you don't have the latitude of giving up on your critical mission of keeping people safe when you're doing these evaluations and analysis. So what are the top considerations that you have to take in place for patient safety when you're conducting all this testing and analysis?
So if you think of the process of installing a new system, you have a design concept. The design process, which is it's done fairly slowly, it's done fairly thoughtfully. You can have somebody else review it, correct some mistakes if they were made. You go into the construction process, again, done very slowly. It's done offline, if you will. Nothing's energized. So you can have checks, you can measure wires, etc. You can check that all out. But where the highest risk is, in my opinion, is during shutdowns. That's where the surprises are going to occur. And that's what you really need to plan for. You need to keep power on all the time. You have patients at the other end of these systems that need power all the time. So you need to get creative during shutdowns. You can't just shut systems down. You're not always going to be code compliant when you do this. At the end of the day, the code says a system has to look like this. But during this transition period, you need to take some liberties. You need to talk to your AHJ. You need to come up with a thoughtful plan. You need to do things like use rental generators strategically. If you're losing your essential power from your existing generators, maybe you roll in a rental generator and maybe you connect it on the emergency side of that transfer switch and do your shutdown. Now you're still doing a shutdown with two sources of power. So like Dan says, fast forward to the witness stand. You're still relatively covered. You did what you could do. You didn't scrimp for time and you didn't scrimp to save money. You did what you could do. You were thoughtful about it. If it doesn't make sense to get a rental generator in, maybe use a different emergency branch and feed that transfer switch. Sometimes in a pinch, maybe even use a different source of normal power. Again, it doesn't meet code, but it gets you where you need to be. It keeps those patients safe, and it protects you should it ever go bad for you. The other thing with shutdowns is looking at the feasibility of the shutdowns. Take small bites.
Yeah.
Don't take a huge shutdown. You're only increasing your risk. So, for example, go into your electrical room, look around, find an empty spot on the wall, maybe install a new distribution panel there. And then just to the right of that, connect those loads now one at a time to that distribution panel. That reduces your risk. And then just work your way around the room. Keep getting empty pieces of wall and installing new equipment. This doesn't all have to be done at once.
Yeah, good points.
Also, when you refeed a new distribution panel or a load center, don't do it all at once. Move those single circuits, those single home runs one at a time. Take those little tiny shutdowns one at a time. You're going to greatly reduce your risk.
Yeah, in my cases, every circuit in the hospital has been shut off at one time or another, and it's really about that controlled small outages that you can communicate, move patients to a safer area, try to isolate those smaller areas to move those loads over under controlled circumstances, and you've taken your liability and your risk to your patients down a lot lower. So I like that idea of a second panel or even a temporary panel that you have to do that with, and then you might have some extra work and things like that, but you do it under a controlled environment where you're not putting your patients at risk at all, which is, it's a delicate balance, and you have to have a lot of thought process behind it. So.
Okay. So I'll take a short pause here because we're kind of at the point of where, excuse me, where we can discuss the analytics side of this. What are you doing to make sure that your facilities are operational, that you understand all your critical points of care? Maybe for the audience, do you have any questions or comments? Okay. All right. So George, you've maybe found something. So when you're integrating with an existing system, so I want to make some upgrade, I want to make some change because I did my diligence on the part that we just. So upgrade in place, replace the whole solution, kind of what's your thought process?
I always like to go for the whole ball of wax if I can afford it, but generally they're not in that situation. Looking back at my past, we had a lot of hospitals, some were 100 years old.
Wow.
That had very old equipment in it, old distribution system, old generators. The generator's 50, 60 years old, you need to replace it. So yeah, an advantage to upgrading in place, you can go in and replace that generator, do a small surgical strike. And the advantage of that is you reduce the cost. But then you're getting what you just paid for. You're getting a replaced generator. That old electrical infrastructure is still there.
Yeah.
I guess another advantage of upgrading in place and reducing the scope, if you will, is you don't get into those code required upgrades. You don't get into things like segregation of branches, which is just a rabbit hole that sometimes just never, ever ends.
So you still your advantage. If I don't touch it, then I don't have to bring it.
If you don't touch it, you don't have to change it, but you're also somewhat doing a disservice to your hospital and your patients because someday you need to touch that.
Yeah.
Someday you need to replace that. If you think about it, most hospitals were built an addition at a time. Each addition had its generator.
Yeah.
Well, that generator is a single point of failure. So if you elect to go that route, you're now acquiescing to that situation. You're accepting that, and you're moving on with that. So there's pros and cons to each approach. Upgrading in place, you limit the number and complexity of shutdowns. So as I talked a few minutes ago, you're reducing that risk by doing that. But again, you're left with that single generator, that single point of failure, no redundancy. So If it's what you can afford, you've made an improvement. But you can also take that a step further. You can go with the, if you will, the power secure microgrid type solution. And you can supply generator power to the entire campus. I mentioned the 100-year-old hospital. There, we didn't have emergency power to the chiller plant. We didn't have emergency power to the imaging modalities, food services, things like that. All the things that you need to keep the hospital running under a sustained outage. But with this, if you take the traditional approach and install more transfer switches, more distribution panels, more load centers, hundreds of miles of wire, you're paying a cost for that. And you're essentially running wires to equipment that already has wires run to it.
Yep.
So if you can look at that microgrid-esque solution and what I've come to call that elegant connection from the generators back to the utility. After those generators fire up and serve the essential loads, after a few minutes, you do that medium voltage switching, and now you have power to the entire hospital.
Yep.
You're essentially an island on your own. You can survive on your own. So that to me, that's the biggest advantage to doing this. 12 years ago, when I crunched the numbers and I looked at the system that I originally had designed and ready to construct, it was about the same price to put my money into generation and not into rewiring something that was already wired.
Okay.
So that really, it helped me with finance.
Yeah.
It helped me with the C-suite, get that approved. The other thing that type of system does for you is it gives you N+1 redundancy. That single generator is not backed up. You lose that generator, you lose that building. So you have N+1 redundancy. Also with this scheme, you have common bus generation. So all your generators go to that bus. All your loads go to that bus. You lose a generator, it's hopefully transparent to you.
Yeah.
All those loads are still served. So I really like that solution. It served my former employer well. We have that system in 6 of 9 hospitals.
Okay.
And I've used them many times.
Yeah, you bring up very good points because wires already run out there. Why run new wires? It's very disruptive to the healthcare environment just to try to do that rewiring. So it makes sense. And then when you start to marry new and old, that's where technology can sometimes become a challenge with your old things that you may not be able to monitor very, very easily, but there's a lot of adaptability out there where in a lot of your manufacturers and things like that can bring in some monitoring that can go on to older gear to be able to monitor so that your engines can see what's actually happening on the load. So makes a lot of sense where if it's already wired and the wire's fine,
Why change? It seems silly, right?
Yeah, it does, exactly.
So if I'm understanding that right, you're kind of suggesting that leave those old generators in place, the older solutions in place, but maybe have a whole facility type generator solution come in, and then you can maybe replace the old ones later because you're not having to rewire the entire facility to go with a whole facility.
That's not the approach that we took. I think Ron has that solution somewhere. But what we did, we replaced all those old generators with a generator farm, if you will, at the head end of the hospital.
All right.
More like a microgrid.
Yeah.
So they're wired in through the essential system. They start, come up to speed within 10 seconds. The red outlets and the emergency lights are energized within seconds.
Okay.
But then very gracefully, after a period of 3, 4, 5 minutes, whatever you select, you make that, again, elegant connection at the medium voltage level back to where your incoming service is.
Right.
And now your entire hospital is electrified.
Okay.
You essentially become a third utility, if you will.
Exactly.
And that, it's a much more redundant system if you do that.
Yeah.
In some cases, it makes more sense. I have one facility that has an older generator on it, and it's a small generator, and it basically takes care of one air conditioning, select life safety circuits out there, a few critical circuits, and that's it. But during a long-term power outage, we have a lot of problems. So we jump into the utility on the medium volt side, bring a generator on. So that first generator only has to start and run for 15 minutes or so, and the second generator is up and online, you're locked in with utility, and the whole building has normal power, and nobody knows what's really going on other than that initial first blink. So.
It's interesting. As I always did, I would walk around the hospital during a power failure and ask the nurses in there, how's things going? You have everything you need? Well, yeah, power came back on 15 minutes ago. Well, I'm sorry, it didn't.
Yeah.
That's a generator supplying that power. You just think everything's normal.
Right, exactly.
I'm providing you power in
Exactly.
15 minutes to the utility.
That's it. Right.
One thing that's not, a lot of people are not aware of is that the grid is going to become more and more stressed, especially in Florida. I noticed we have Kevin Hinton from Duke Energy on the call this morning. It's no secret why demand response down here is getting a lot of play. When you're talking about, I think it's $8.11 per kW, just for the promise to run those generators, ROI looks pretty good. But Florida Power and Light, Duke Energy, they are aware that more people are moving into this area. And I was driving from Orlando to Tampa the other day, and it looks like one city. You know, there's buildings everywhere you look, most of them distribution centers for Walmart and Amazon, for instance. The grid is more vulnerable now than it's ever been. And I think people are beginning to realize that the EPA takes a back seat when it comes to emergency power. We'll see what happens. But I think that's on Trump's agenda to address that. But one of the things that George brought up a while ago about the having multiple sets for backing up. A lot of people think that if you've got multiple sets, you don't need to have a connection point for a portable generator in case one of those generators goes out. That's false. If you look at 700.4F, I think is the number, it states specifically that you need to have one. But let's say that you decided not to, and you've got your distribution planned so that all the generators that you've got are needed to supply all the loads. And if you lose one, it starts shedding loads. Well, when you start shedding loads, you got to remember that you have load creep that exists in every facility. People are adding loads on. So you got to keep a real good eye on just exactly how much power it's going to take to keep all those important loads electrified, if you will. It's a moving target. And that's the reason that the power monitoring equipment is so dadgone important these days.
So those are great points, Dan. So let's maybe talk just a little bit about some of the, so utilities have a lot of capacity constraints with new large loads coming on. Y'all are bringing new large loads online inside these service territories. The utilities are getting very creative in incentivizing you as healthcare facilities to be able to utilize your behind the meter solution, or maybe they want to put a solution that you own in front of the meter, so it could be like a supply side resource to them. What types of programs are interesting to the healthcare industry that are, that makes sense for me to participate in some type of rate structure or interruptible load program?
Well, I mean, in my cases, you really need to look at what is the impact to my operations overall. If I'm going into a demand response program, how often is that exercised? How often do we have to do that? Is that just a test once a year, or are we doing that weekly?
Right.
If you look at peak controls type situations where you're trying to control your peak, does that make sense? It kind of goes back to what your risk tolerance is and your risk assessments again is, it's not about making money. It's more about saving money, but keeping the impact to your facility down. In my case, I do demand response, and it helps a lot. From a financial side of the fence, it's very good program to be in, but we're lucky that we don't have to use it very often, other than a test a year. Then you have to start balancing whether it's right to, what's it cost me to run my engines? What's it cost me to staff personnel when those engines are running? What's it cost me in fuel? I mean, our fuel prices are up and down. When they're up, it's very expensive. How much more maintenance am I gonna have to do on the engine? Am I gonna trip an interval where I've got to do some major things to my engines or my systems out there to do it? So does it make sense? And those are really individual facilities questions that you have to dig deeper. You can't just say, oh, look at the money. Well, that's only a one puzzle piece of the whole puzzle.
So you can't chase just the dollars with the initial capital that it takes to put the solution in place. You have a whole lot of other things you got to consider, right?
I believe you. I believe so.
Yeah.
Yes, George. I mean, that when you're in a different way.
I agree your sentiments, but I think pretty much wherever you're in the country, it feels about the same to me.
Right.
I think from my perspective, what I liked was chasing free money for the most part. I think if it looks like free money, I think it's palatable for a healthcare organization. It's not our core competency.
Right.
But if it's essentially free money, and what I mean by that is in an 8-year period that we participated, we were dispatched one time.
Right.
But yet we were paid every year.
Yep.
That feels good to me.
Yeah.
If we're dispatched 5-10 times and it's in the middle of the afternoon and we have 20 ORs going, it starts to not feel so good.
Right.
But I think that chasing free money is very palatable.
Oh, yeah, absolutely.
So you bring up a good point there. So what if the incentive program from the utility was for them to own that power plant at your facility instead of you? Because you said it's not our core competency to maintain a solution like that and make sure that it's always going to be operational. Does that flip the script a little bit on you? I mean, is it the healthcare facilities really say, "Oh no, I'm not interested in that utility owning this. I want to own it."
I think it depends how it's schematically configured.
Yeah.
If you're transmitting power back into the grid, I think that's a whole different subject. And I think that's fairly safe. If you're taking your load off the grid,
Yeah.
that's different.
Right.
Because now you're doing internal switching. Something may go bad when you're doing that switching. I think that's where the risk starts to increase.
So you're making a conscious decision of taking load off. So then you got to get back to what we were talking about in the beginning of this, right? My number one mission is patient care.
Absolutely.
Yeah.
That's our core competency.
Yeah. I'm good.
Anytime you blink power in healthcare,
Yeah.
People's eyes wide open, oh, okay, we got, we power go black. We got 10 seconds to get power back on. Count to 10 in the dark. It's an eternity when you're in a black building. So you have to really weigh that out, whether it's worth the risk. And I kind of agree with what George, I'm not sure I'd want to do that.
So 10 seconds is a lot longer in the dark than
Feels
when
like
the sky's blue.
I had a nurse come in one time using an elevator for 5 minutes with the lights out.
Yeah.
It was 10 seconds.
Yeah.
But she was scared.
Yeah, absolutely.
So
I think the EPA is going to finally come to their senses and admit that an emergency occurs before the outage, not afterwards. A good analogy is going down the back straightaway at Daytona at 200 miles an hour and your car gets airborne. While you're upside down in the air is when I think the emergency occurs. When the car hits the pavement, that's the wreck. But you've already had the crash. And the EPA so far has not bought off on that. But if they were to use a little common sense, did I say that? I think I did. Then they would come to the realization that the emergency occurs before the grid is dropped. So anyway, we'll see what happens.
So Dan's brought up the EPA a couple of times. So I'm going to try to ask this question the right way. I might need to modify my question a little bit. But so EPA regulations allow for a Tier 4 final certified engine to run. Now, there's a lot of caveats, but more or less unencumbered for the amount of time that you want that engine to run. So is that beneficial to healthcare to have a generator that you can bring online? Maybe there's not a power outage. Maybe there's some blinks that you want to try to take out of the equation. Is that something that's interesting to the healthcare industry?
Well, I mean, I'll take the first stab at this, but from my in South Florida, we have and FPNL, please don't take this bad. Flicker and lights out or whatever. I forget what Florida power and lights out. But we have a lot of areas where you'll get sags and dips in voltage,
Yeah.
and you'll start to, critical equipment inside the hospital is getting tighter and tighter tolerances for power quality. So it makes a lot of sense to be able to, all right, the power's there. Let's just go ahead and go over onto generators. And we're going to sit there through the duration until surgeries are done, until the grid is much more stable, and not worrying about how many hours am I running on this engine.
Right.
Am I going to trip an EPA issue with this or not? So it does make a lot of sense depending on where you're at in the county. A lot of hospitals out there, I think most of them will have redundant feeds coming to your building. You'll have your primary and your alternate. If you're on your primary, generally those are going to be more stable. But if you go to your alternate feed because the power service is working on their primary feed, now you have a lot of residential loads, you have a lot of tree issues and things like that. You start getting a lot of blinks in power, and it really will bring our surgeries to a stop because of the sensitivity of the equipment. So it makes a lot of sense to be able to be a tier 4 final and run those engines without worry, at least in my case.
Yeah, absolutely, I agree. That's probably the biggest thing. I think in the last 12 years, there were at least 3 occurrences where the local utility was having issue with the lights blinking coming off and on. And the operating room's in a panic. They're calling down what's going on. Should we stop? Can we start? What do we do? And we just went over on generator power and just stayed there all day until the local utility said, we're okay now, regardless of what the issue is. Right. And then I lived a lot of years in your shoes. I think when you get into any sort of electrical situation, you can't write a prescription for what those solutions are 10 years from now. But by God, if you have 3 or 4 good options that you can choose from, it usually gets you out of trouble. So if that's just another option for you to go with, I think that really comes in handy.
So you could be double dipping, maybe triple dipping here, right? Is that, okay, I'm taking a substantial reduction in greenhouse gas emission by going to a tier 4 final engine first off. Then if I want to run that on renewable fuel, I'm taking another step to where my reporting of those emissions is really going in the right direction, making your board happy, making the owners of your healthcare system happy, right? So,
Absolutely.
yeah. So we've kind of got to the point of, we did the analysis, we found some points of failure that we may need to address. We talked a little bit about replacement versus adding to existing systems, and probably should have asked this question kind of earlier in the equation, but since we're using this as a WebEx that we're going to record and we're sending out, how do you pick the right engineering firm? I mean, how do you get, because you guys are busy, right? You can't design everything down to that level. So you do need engineering firms to be in the equation sometimes. How do you pick the right one?
I'll go first. I've been blessed the last 20 years with a really good, solid engineering firm. And probably like most, we don't put all of our eggs in one basket. We have a couple different engineering firms we work with, but we have that house engineer.
Yeah.
And I've seen enough things go wrong with the come and go companies. It makes me really appreciate that house engineer. I think first and foremost, what you want is you want an MEP firm that has healthcare experience. Absolutely, that's a prerequisite. You want to have when they're doing their design and thinking about constructability and the shutdowns to come, you want them thinking every one of these loads serves a critical patient. You want that mindset in the design. You want it baked into the design. You don't want somebody to think that the last job they did was supplying power to freezers in a grocery store.
Yeah.
It's a total different mindset.
Yeah.
You don't want that. You want a firm with talented and creative thinkers, not just somebody that can crunch the numbers, but talented and creative thinkers. Everybody's heard, everybody has a plan until the first punch is thrown.
Yeah.
Well, that's what happens during the shutdowns. There's going to be a surprise, and you better have good, talented people there to help you get through that in 1 minute, 5 minutes, 10 minutes. You better get through that quickly.
Yeah, like what Dan said earlier, everything works until it doesn't. Right?
Exactly.
Yeah.
Exactly. That's a good rule. During the design, you want a firm that considers the complexity of the shutdowns during the design. You want to begin with the end in mind. we're designing this, but one day we need to implement it. We need to construct it.
Right.
We need to do shutdowns for it. If we can make the design more palatable for those shutdowns, that's a huge win. And finally, you want a firm that works well in the integrated project delivery model. You want a firm that works well with the contractor. So that during the initial design stage, during schematic design, they can show this to the contractor and the contractor look over it and say, I don't like how you did that. I can't build it that way, or it doesn't make sense to build it that way.
Yeah.
Go back and change that, and they do. There's no egos in the room. They happily go back, change the design, and at the end of the day, you end up with a much, much better project, much safer project.
So the MEP firms that you get, they really need to be working as a team, as in conjunction with the staff on site, with your contractors. Kind of, all right, here's where we want to get. Now we got to walk backwards and see, how does the contractor actually get to the means and methods of how they're going to do it, right? Great design, I just can't make it happen, or I need much more longer time than anticipated to make this section happen. More money. So it's really, they have to be creative thinkers outside the box, because what worked for you may not work for me, and vice versa. And so they have to really look at the building individually and be familiar with the building. Kind of, it's very hard when you bring in a brand new MEP firm into an existing building, for them to get to know their way around. How is this laid out? How do you get from point A to point B? Where's all this power run at? What are we going to do in there? Is there old technologies, new technologies, things like that? So you really need somebody that can dive into the details and really come up with a PACE model, a primary, alternate, contingent, emergent plan. To get you through all this. So,
Understand. So, any questions, comments, concerns from the audience? I saw something pop up, but I couldn't read it quick enough.
Yeah, so it's another component this is from Jeff Cook at Reed Health. Another component that is overlooked in codes and standards is IT and their electric and cooling needs that impact the hospital's infrastructure and operations.
That's key, Jeff. That's a very good pickup, because more and more our world is IT driven. Everything is IT driven. The requirements around cooling and things like that. We have CTs that are cooled, that are water cooled. They're cooled by chilled water. When you have a chilled water shutdown, all of a sudden now you have an issue. But even power, you take down one CT, are they both on the same switch? How are your rooms divided? But when you come in and look at your IT infrastructure, where's the power coming from? A lot of the old systems, they might have had a redundant UPS or rotary power type system out there. Do you have them on generators? In a lot of cases, they may not be. They might have been a normal source fed to a UPS. Right? That UPS has 40 minutes of runtime. But has it ever been tested? How often are the batteries looked at? So that brings up a whole nother really deep dive into a risk assessment when you start looking at the IT infrastructure.
Absolutely. And you do that risk assessment, and it comes down to not knowing what you don't know. You may not find two things that you don't discover until the power's out for 4 hours.
Right. Exactly.
And going back, that's the beauty of the microgrid solution. I talked about running wires to equipment that already has wires run. If you go with a microgrid solution for your chiller plant, everything's solved for you. The conventional approach of trying to get essential power to everything you need to run a chiller plant or IT, if you try to make a list of everything that you need power to, you're going to miss something. You're going to miss a board in your BAS somewhere trying to get that chiller plant running, and you're not going to know until the day that you need it. With that microgrid solution, everything has power.
Yeah.
It's almost bulletproof.
Yeah, that's where, I think the power secure solutions they've come up with for us have been, cutting edge and things that were not thought of in the industry out there very long ago. And they've kind of really come to our rescue in a lot of cases where we have no physical ability to expand. We have to put a platform in an existing space that you pulled an old engine out and be able to put it back in, and then, start to look at, all right, do we do the medium voltage gear, bring it in? Because that just solves a multitude of issues in areas that, your business occupancies, we all have occupancies that are mixed. You have a business occupancy next to a healthcare occupancy, next to a business occupancy, and they don't have power. But now when we come in with the power secure solution, the microgrid, that solves all that. And all of a sudden, boy, we never have power outages. Well, yeah, we do. We just don't realize that. And it works well for us. I mean, it's been a game changer for us.
Back to your example. It was only 10 seconds. Don't get over it.
Right. Just felt like 5 minutes.
Yes, felt like that.
Right.
All right, well, I really appreciate y'all's time today. Thank you for taking time to talk to us and talk to the audience on the phone. If there's no more questions, then we'll give everybody a few minutes back of your day. Thank you.
Appreciate it. Thank you, everybody.
Thanks, guys.